My name is Ting, and he is my coworker.
Hi everyone, my name is Ming.
And we are going to discuss our new findings regarding document exploit techniques. Okay, so let me introduce ourselves first. We are security guys from Taiwan. And where's Taiwan? Yeah. Here's Taiwan, okay. So we are also members of Chieh security group. Basically, it is a study group. And we share information, we're doing research, and we're writing books together in Taiwan. And also, we host the largest technical security conference in Taiwan. We call it HIT or HitCon. And HitCon 2011 just finished successfully 2 weeks ago.
Hi, my name is Ming. You can call me Nanika. I'm in sensor vulnerability research in Ming in Taiwan. My research topic includes vulnerability research, exploratory technical, malware detection, and mobile security, especially on Windows platform. I have started work on document security research since 2004. I have discovered many Windows and Office vulnerabilities, and some of them have been published.
Okay, I'm Ting. You can just call me TT. And I'm security researcher as well as security developer in the Chieh Micro. And my recent research includes malicious document and automatic malware analyzing system, which is somebody called them a sandbox technology. I'm also interested in malware detection, system vulnerability and protection, web security, and cloud and virtualization security research. Okay, so let's get back to the topic. Here is the agenda of our presentation. In the beginning, we will talk about APT and targeted attack. This is also the motivation of our research. And the second, we will talk about techniques have been used in recent document exploit. And then we will introduce 4 major technical topics of document exploit in future. So, we will focus most of time today in the feature document exploit technique. Then the conclusion. Okay, the term APT, I think everyone should know this now. This term has become very popular in 2011. Recently, RSA and Commodore has been targeted and hacked by APT attack. And many proof shows some sensitive information has been stolen. Lockheed Martin was hacked as well. Actually, we are not surprised by breach news. We have known this kind of targeted attack since 2004 in Taiwan. The real attack is probably earlier, but at least I know this in 2004. Okay, due to the political issue, government units and large enterprises in Taiwan has been targeted since many years ago. They have kept receiving purpose-made emails and malwares and exploits, never stopped. So we have a lot of opportunities to observe these attacks. Nowadays, not only in Taiwan, this kind of silent threats are attacking whole world, especially government and large enterprises. I think you should already heard something about this. Okay, unlike other cyber criminals, they are hacking for they're hacking for information. Okay, unlike other cybercriminals, they are hacking for information, not profit. For example, Komodo issues certificates and RSA secure ID, which is used by a lot of customers. And no need to say Lockheed Martin. They have much sensitive information as well, especially related to national security. Attackers are targeting your sensitive information. So even you have already deployed security devices, you have already installed software, security software, and they could still penetrate into your corporation internal networks. So how do they attack? Usually, attackers send an email with specific content. The content looks very real. Actually, they copy the content from real mails. And in most of cases, the mail also has a document attachment. And the attachment is usually the document exploit. And because it is kind of targeted attack, your enterprise software couldn't detect because the exploit is customized. After you open the document, attacker can take control of the victim's system. So you couldn't block email, so use this way is always effective. In early days, like before 2008, attackers like to use document exploit of Microsoft Office applications, like Word or Excel. And in these years, attackers start to change. They like to use PDF, Flash, and malicious web page. Here is another sample. And it looks very real. Okay, and sometimes we could see tricks like this. Actually, it is not a document. It is a PE file with RTLO Unicode file name. So it is actually a SCR file, and it is executable. So after click, you will launch a malware. Okay, so this is most common way of targeted attack, and not easy to be aware of. Unfortunately, most of security software couldn't do protection effectively. So we may say document exploit is actually the weapon of targeted attack. Attackers use document exploit as the weapon. They spend a lot of resources to develop these weapons. Okay, so let's back to the technical topics. We're not gonna discuss any political issue, only technical contents. Okay, question. If you have installed all Microsoft Office pages and there is no Office 0-day, and will it be safe to open a Word or Excel document? You know the answer is no. Why? Because this might be a hybrid document exploit. This is the first recent document exploit technique we want to mention. The design of modern document application is very complicated. Most of them could embed document objects of other applications. The document might embed an object of other applications, and other applications could be vulnerable. So, for example, your Office is okay, up to date, and no problem. However, the Word document might embed Flash object. The object could be an exploit, which is attacking Flash vulnerability. So you will still get on after you open the document. Most of people know browser could include a lot of document objects. So they are cautious when they open web page. However, when they open a document in the email, they will not be aware of the danger. So we think application has become an exploit platform. The Flash exploit may be run on Excel and other applications. This kind of attack is popular recently. A Flash vulnerability could be repacked as a malicious web page, a PDF exploit, and Office document exploit. Recently, we saw a lot of attacks using this trick. RSA is the same. RSA attack is the example. The Excel Flash is actually the Flash vulnerability, and it is packed as an Excel file. Okay, so question. Why RSA attacker choose Excel? Why not use PDF or web page? Because of DEP. Actually, we have disclosed this trick last year. Let's see our demonstration. We will show you why they use Excel and not use PDF.
We are going to demonstrate how do we use Office to disable DEP. First, we configure DEP to turn on for all programs and service.
Now DEP is configured to be enabled for all applications.
Then start Excel. As you can see, the DEP is enabled now. Let's try to insert an ActiveX controller. This trick can insert any ActiveX controller, include Flash object. And we save as this file. Then turn off. Now open this file again. As you can see, the DEP is disabled automatically. It's very difficult. No, it's pretty easy. However, this trick doesn't work on Office 2010, and the DEP is configured to always on.
Okay, so use this trick. It is much easier for attacker to write exploit because they don't need to care about DEP. Okay, so the second recent document exploit techniques. It would be attack incomplete protection. The exploit mitigation techniques could do a really good job to avoid exploit execution. Like DEP and ASLR makes exploit writer headache. And yeah, it is really useful. However, it is very difficult to do protection completely. It is not easy to adopt protections to every single module. Even you have adopted DEP and ASLR, there are always some researchers could find some modules are not protected by ASLR. Thus, they can use ROP techniques to bypass DEP protection. Here is the example. The address of these modules are fixed and could be used. So they could use this to do ROP and to bypass DEP. So the protection might not be complete. Yeah, okay. The third one, not only finding bugs, there are some advanced memory attacks have been published recently, such as return-oriented programming. The ROP is a technique to bypass DEP. However, if you enable SLR, ROP is become harder. And also flash JIT spraying. JIT can defeat DEP protection, and spraying can defeat ASLR protection. So use this trick. We can defeat DEP and ASLR. Of course, vendors have responses to these advanced exploit techniques. Microsoft released EMET, the Enhanced Mitigation Experience Toolkit. The tool can provide more advanced protections and make protection more complete. For example, if ASLR is enabled, it is not easy to do ROP, right? And you need to find some modules that is not protected by ASLR. And many researchers are doing this now. However, even you can find some modules to use. Once it adopts EMET, these modules are also protected by ASLR. So ROP become even harder. And also, Flash has started to encrypt AVM code area since version 10.1. So Flash JIT spraying doesn't work anymore since 10.1. Not only encrypt AVM code, new version of Flash also provide better ASLR. So it is difficult to write exploit for Flash. So these advanced protection technologies make ROP and JIT spraying more difficult. However, later we will show you how do we defeat EMET and bring JIT spraying back again. Okay, so these recent document exploit techniques. These are recent document exploit techniques. Now we are going to introduce the techniques might be used in future. And we will also provide our techniques and demos. Okay, we think document exploit research will focus on these four major areas in future. The first, hackers will keep improving their fuzzing techniques. They will try to find more vulnerability. And then the second, techniques against exploit mitigation technology. For example, hackers will find new ways to defeat DEP and SLR. And the third, hackers will also focus on the techniques to bypass sandbox and also policy and access control. And the fourth, techniques to defeat behavior-based protection and auto-analyzing sandbox. I will explain this later, why hackers need to doing research on this now. Okay, the first, file format fuzzing techniques will be kept improving. I think not only big guys, we know our vendors such as Microsoft, they are also improving their file fuzzing techniques. They will also want to find more vulnerabilities. Okay, we will take Flash as the example. Recently, fuzzing Flash is kind of popular activities. So many people are doing this, and a lot of Flash vulnerability have been disclosed in these years. So we also found a few critical vulnerabilities. Okay, this is a hex picture of a Flash file. Traditional fuzzing is trying to change each byte with all values, and try to make some files that can crash Flash. So here's the example. Try each byte and each value. So during the analyzing of Flash vulnerability, we found that ActionScript part, the AVM part, is actually the major parts that could cause the problem usually. So we would like to focus on the code area of AVM instructions. So in our fuzzing techniques, we don't try to change each byte of all file. We just focus on the AVM part. As you can see, it is the structure of the Flash file, and we only focus on the code area. And not only in code area, we only focus on the AVM instructions. There are only around 170 AVM instructions. So we don't need to try 255 times. It reduced the testing range and saved a lot of time. We also discovered APSB 1112, the vulnerability, before it is disclosed by our fuzzing techniques. Here is the picture. Shows we try each instruction with random compositions. And the right-hand side is the Flash file, and we use the random composition of AVM instructions insert to the file, the method body area of Flash file. And in this way, we can generate different files, and we try to open, and we see that does the application crash. Okay, not only find vulnerabilities, we accidentally found the Flash jet spraying technique could still work. This will be introduced later. Okay, the second type of attack will be attack to exploit mitigation techniques. Researchers will find new techniques to defeat DEP and SLR in future. Definitely. So we are going to introduce our Flash jet spraying techniques as the example. This technique not only brings jet spraying back and is able to defeat Microsoft EMET protection. Okay, so the key reason, the magic before instruction. If we replace the first XOR instruction with before, the AVM code area will not be encoded in memory. So with this trick, the AVM, the JIT spraying could work again. Here is the description of the in instruction. In is the before. Okay, so let's see the demonstration.
We are going to show how B4 works. This is a Flash player. The latest version of Flash is 10.3.181.34. And the Flash file will use the original XOR technique to do JIT spraying.
Okay, now we use the newest Flash to load the original XOR trick, JIT spraying. This is old way. Now we attach the process.
Now we attach the process and find the any XOR institution in memory. The 90-90-93C35 is the spraying content.
Yeah, the old JIT spraying trick is using this content to spray in the memory.
And we search the list. We could find the XOR in the memory.
Yeah, we couldn't find this because the instruction is encrypted.
Then we use the hex editor. Modify AA to B4. And save the file. Now we load the file again. The same, attach process and find the spraying content. This time we can see XOR institution in the memory.
Yeah, instruction is here, so not encrypted.
And we disassemble this. There are XOR institution.
Yeah, this is the signatures of the previous JIT spraying technique. Okay, so you can see the before trick can really bring JIT spraying back, fresh JIT spraying back. However, there are still some problems. Not only the encryption. After recovery the AVM code in memory, we encounter a continuity problem. The original trick used a loop to load a flash file to do spraying. So it is a loop to load a spraying file many times to do spraying. Like this, in a loop, and load the same flash file. And in the memory, you will see there are a lot of copies of the file. But in new version of Flash, there will have bad continuity in new version of Flash. The continuity is bad. It will be separate, not in the same area. So, in order to have better continuity, instead of repeat reloading another flash file, we use a big file to do spraying. This picture shows how do we make spraying file. We make a lot of metal body section in a flash file directly. As you can see, the right-hand side is the flash file and include a lot of metal body. And each metal body include a lot of XOR instructions. Yeah, use this way to spray the memory. This approach has a much better result. In our testing, we have around 10,000 metal body in a flash file. And each metal body includes 2,045 XOR instructions. Yes, you may ask how big is the file. Yes, exactly. This technique produces a huge file. In our testing, the file is around 58 megabytes. However, the Z library can do a lot of help. After compression, the file size reduced to 268 kilobytes. So we use, and then we use our own tool to generate the file. We couldn't find a flash disassembler is able to load this file because this file is huge. And so we need to write our own tool to generate the file. The tool is Sprite as well. Okay, we have another findings for the juice spraying technique. Instead of XOR spraying approach, we found that use OR would be better. The original weight is used 3590909003C. Use this string to spray the memory. And we don't, if we use OR, the spraying content will be 0D, 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 and 0C. And why? This technique makes it easier to jump into our spray area when trigger the vulnerability. We can see this example. You may see that okay. The EDX is important. The value of EDX is important, and the value of EDX will be the value of EAX plus C, the value of this address, right? So, oh, sorry, the EAX plus 70. And okay, as you can see, the EAX value is 0C, 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 0C. So this value plus 70 is this place. So this value will be moved to EDX. Okay, so if we use old trick, if we use XOR spraying, the value of the code will be the one of the combination, one of the possibility of the XOR spraying string. It could be start with 35 or start with 90 and or start with 3C, and this value is the destination is difficult for us to spray. And if we use OR, the value will be much simple for us. Yeah, the destination will be start with 0D or 0C, and that area is easier to spray. I know maybe this is not easy to understand. Just remember when you are testing flash JIT spraying, use OR. Okay, our flash JIT spraying can defeat all protections, even the EMET version 2.1. Okay, let's see some demos.
In this video, we will show you how MS11050 works with our JIT spraying. The flash is the latest version. The exploit will load the qload.swf. The qload will be.
This is the latest version of Flash. Okay, here is the exploit.
The exploit will load qload.swf. The qload will be in charge of JIT spray, and the document.write iframe will trigger MS11050. Open the exploit. Now Flash is spraying the memory. After trigger the exploit,
now it is spraying the memory, so it takes time.
our shortcode has been executed and the notepad is launched.
So this demonstration shows our JIT spraying technique could be used in latest version of Flash, and if you have a vulnerability, you can use this trick. Okay, so now we are going to demonstrate how do we defeat EMET.
In this video, we will show you how JIT spray defends EMET. Now, you can see the EMET in the latest version. And we enable all protection.
All protection are enabled.
As you can see, the Flash version is the latest beta version, Flash 11.
Yeah, this time we try Flash 11, the latest beta version.
Now, we have two word files. The first one is in charge of load the flash and spray the memory. And the second file is the CVE 2010 3333 explorer. Now open the first file. You can see it's spraying in memory.
The first file in charge of the memory spraying. So now it is spraying the memory. This word file will load a flash. The flash will in charge of the spraying.
And check the library list. The EMET is low. DP and SR is enabled.
Yeah, EMET is loaded, and yeah, DP and SR are enabled.
When spraying finish, we load the second file. We can see no pad is launched, and it's fully bypass EMET.
Yeah, the exploit is triggered and shell call is executed. So Notepad is launched. So our trick can effectively defeat EMET protection. Okay, now we are going to have a real demo of the. We will try to see the after spraying. We will see the what happened in the memory.
Some people ask that, do we really use a single file to do spraying? Let me demo this. In our testing, it should take around 30 seconds.
no flash is spraying the memory. So yeah, it takes time, around 30 seconds. And after this, we will attach IE to see the memory. Okay, loaded.
We can see our spraying code is the RE session, and the session content is our spraying content.
Use original trick. The flash will you will not see the RE sections here. Yeah, because the flash new version of flash will protect the memory. So use our trick. You may see the RE the executable area again. And the executable area include the content we sprayed.
And now we demo about EMET. The win word is protected EMET.
The word is protected by EMET. Now it is also spraying the memory now. And the EMET will affect the memory arrangement. So we also we are interested in the memory sections after EMET.
Then we use OE debug attach win word. You can see the three. You can see there are always our spraying content at the three addresses. One is 0A, 0B, 040, and 0A, 0B, 40, and 0B, 0C, and 0C, 0D. So if we control the EIP, then jump the three address, it maybe work.
Okay, this demo shows that even even EMED is enabled, there are still some tricks that we can use to write exploit. Okay, except for memory exploitation, the attack to design of security policy and resource access control will be another topic for document exploit researchers. So this is the third future document exploit techniques. So attackers will focus on this now. I think there are a lot of research will be published recently regarding sandbox bypass or defeating sandbox. In order to provide secure execution environment for clients and users, vendors are starting to adopt sandbox technologies to their application. The sandbox usually has complicated policy and complicated policy and permission settings, and it will try to isolate access to each resource. So it is complicated. So the protection might have two problems. The first, incomplete protections, and the second, there might be some logic design flaw in applications. We take this Flash sandbox flaw as the example. There are 4 types of Flash sandbox settings. The basic idea of default settings is if you can access network, then you cannot access local resource, and vice versa. If you can access local files and you cannot connect to network. So in our example, we are using local files. So the setting would be security.local with file. So it allows to access local files and not allow network connection. The flaw is in its URL protocol design. We embed a Flash object in an Office document. It works on Word as well. So this Flash object is allowed to access local files and not allowed to access to internet. So it is okay to access files in your disk, and it is not to connect to internet. It is the policy control, sandbox control. So, however, there is a problem when handling the MMS protocol. When the Flash object opens a MMS link, IE will be triggered, will be launched, and then media player will be launched as well. It is launched by Internet Explorer. The media player will connect to the link. And still, you can still access local files. So this approach breaks the sandbox setting. With this flaw, we might steal users' cookie and users' saved password and other information. And we might use this technique to probe user environment. Here is the simple code of this approach. Okay, let's see a demonstration. This problem is still a 0-day, so could be used in a attack.
We log into Gmail, and the browser will save the cookie in local disk.
Okay, now you can see the cookie is saved in the disk.
And then we start a server to listen MMS connection on port 1755.
Yeah, this server is going to listen the connection from the client, from the victim. And 1755, this port is for MMS.
Open the exploit media player, send the cookie to our server automatically.
So let's see again. Okay, now click the exploit, and exploit will launch IE, will launch media player, and media player will the flash load cookie, and the cookie has been sent to our server. So use this cookie, we can log into use this account to log into Gmail. Okay, in case of IE6 and IE7, as you can see, the code launches IE and media player automatically. The information will be transferred out. And however, there will be a pop-up warning message before opening media player when you are using IE8 or IE9. So for IE8 and IE9, we may use some tricks to interact with users. For example, we can create some animation or with links, and after click the link, I think most of users will still click yes to allow the connection. Okay, so in case of exploit is launched, traditional signature-based malware protection is useless, because the exploit or malware is usually customized because it's targeted attack. So users can only rely on behavior-based protection. For example, the host IPS, it could block your connections to internet, block your file dropping to system folder, and block access to sensitive registries. Therefore, defeating host IPS will become exploit writer's next major task. Okay, so the first trick, bypass inline hook. Many host IPS use inline hook to intercept API and monitor behaviors. And most of them are using Microsoft Detour library or Detour-like approach. They bypass this kind of API hooking. We may just skip a few beginning bytes. Yeah, here is this picture shows the example. On the above bar, this is the function, and which is hooked by Detour library, and Detour will set a jump in the beginning byte of the function. And when we want to bypass this protection, bypass this API hook, we may just jump to the address of the function and plus a few bytes. Then we can bypass the protection. And before the jump, we need to create the values in the stack. Thus, after the execution, the control will back to here. Okay, so the next trick, WMI and COM. The host IPS usually does hook to observe malicious behaviors, no matter in ring 0 or ring 3. Once it detects a suspicious behavior, for example, if a file is dropped into your system folder and a sensitive registry key is being modified, the host IPS will check who is doing this and check who is doing this by identifying the process. So try to imagine if legitimate process could do things for us, the host IPS will become useless. The host IPS could not block or kill process. Host IPS cannot kill or block system process. And usually, this system process is in the whitelist in host IPS. We noticed that Microsoft has already provided complete solutions, the WMI and many useful COM objects. By leveraging the technologies, system process could do everything for us, including connection to internet and access file registry and even installing a MSI file. Actually, not only system process, some general install applications could do the same things as well. For example, Word, Excel. They can, because they provide COM interface, so they can do things for malwares. Okay, not only defeating host IPS, this approach could also defeat automation analyzing sandbox system, because the malware process actually does nothing directly. The sandbox could record nothing if the sandbox only track malware process. So we have some tests. We just use our test file in sandbox, and the sandbox can record nothing. Okay, this picture shows malware can ask system process to do things for him through COM interface, access registry file network, and process operation. Okay, we have demo. The demo will show you how do we defeat host IPS like McAfee host IPS and Commodore host IPS. Okay, so this demo, now we have two exploit. One is use traditional way and try to exploit to launch Notepad, use traditional way, and another is use our way. Okay, so now we open the use original way to launch the exploit, Excel exploit. Okay, it is blocked by McAfee host IPS. And the same vulnerability. We use our trick. Okay, so now open the second file. Okay, so you can, as you can see, this time a Notepad is launched, and it is launched by the WMI service, right? Okay, next demo. Okay, this time we're gonna defeat Commodore host IPS. And first, we configure this to paranoid mode, so it could detect all behaviors. So now it shows Excel is a safe application. Would you like to start? Yeah. Okay. And we start the exploit. Okay. And now it detects the exploit, so it could ask user to block this. yeah, this Excel launch, this exploit is blocked. And then we use our approach. Would you like to launch Excel? Okay, this time the same. Yeah, Notepad is launched, and host IPS know nothing. Yeah, we can just start the process. Okay, so the conclusion. We have discussed 4 major areas that document exploit researcher might focus on in future. And also demonstrate our findings in this area, including AVM fuzzing techniques and new flash JIT spraying and attack policy flow and WMI approach. We believe attackers are working hard on these topics as well. We wish security vendors could address these problems to come out solutions ahead of attackers. Okay, this one shows one of the scenario of that hackers can use. Okay, vendor keep patching applications and inventing new technology to prevent attack. Attackers always can find ways to defeat those protection. So we think it's like a cat and mouse game. So we wish application security vendors could be aware of the attack and have new approach to protect people. Okay, after the presentation, we're gonna release this proof of concept. The all white and white is old and new JIT spraying technique. So you can compare the difference. And MS11050 is the sample. It is real exploit with new JIT spraying approach. And qload.swf is the file in charge of the spraying. And notepad.cpp is the shellcode for launch Notepad using WMI interface. Okay, thanks. This is our blog, and yeah, thanks for coming. Thanks for listening.